Hey everyone, welcome back to the channel. Before we jump into today's diagnostic guide, take a quick second to hit that subscribe button, turn on the notification bell, and leave a thumbs up if you find our content helpful. It really supports the channel and helps us keep producing these detailed automotive troubleshooting guides for you every single week. Today, we are tackling one of the most common and dangerous automotive emergencies, engine overheating. Few things cause instant panic like seeing your dashboard temperature gauge creep into the red while steam billows out from under your hood. But when an engine overheats, three primary components are almost always at the top of the suspect list: a stuck thermostat, a failing water pump, or a clogged radiator. The tricky part is that all three cause the exact same end result: heat building up in the engine block, so throwing random parts at the problem gets very expensive, very fast. In this video, we are going to break down the distinct symptoms, mechanical behaviors, and step-by-step physical tests for each of these three cooling system components so you can pinpoint the exact culprit in your own driveway without wasting money on unnecessary repairs. To diagnose an overheating issue accurately, it helps to visualize the loop your engine's cooling system uses. Under normal conditions, the water pump continuously circulates liquid coolant through the hot engine block and cylinder head. The thermostat acts as a temperature-sensitive valve, staying closed when the engine is cold to help it warm up quickly, and opening up once the coolant reaches around 180 to 200 degrees Fahrenheit. Once open, it allows the hot coolant to flow through the upper radiator hose into the radiator, where airflow cools the liquid down before it exits through the lower radiator hose and gets pumped back into the engine. When any single piece of this continuous loop fails, the thermal cycle breaks, and engine temperature surges out of control. Let's begin with suspect number 1, a stuck closed thermostat. The thermostat is a mechanical spring-loaded valve containing a small wax pellet. As coolant heats up, the wax expands, pushing the valve open against spring tension. If that wax mechanism leaks out or the valve mechanically jams shut, coolant is permanently blocked from reaching the radiator. The most telling symptom of a stuck closed thermostat is a dramatic temperature imbalance between your upper and lower radiator hoses. After your engine reaches operating temperature and starts running hot, carefully touch or use an infrared thermometer on both main radiator hoses. If the upper hose coming from the engine is extremely hot and pressurized, but the lower hose returning from the bottom of the radiator remains lukewarm or completely cold to the touch, your thermostat is almost certainly stuck closed. Another key clue is rapid overheating. A stuck thermostat will cause the temperature gauge to spike quickly within just 5 to 10 minutes of starting a cold engine, regardless of whether you are idling or driving on the highway. To confirm it definitively, you can remove the thermostat and place it in a pot of water on your stove with a thermometer. As the water boils, you should see the valve visibly open wide. If it stays shut in boiling water, it is dead. Now let's examine suspect number 2, a failing water pump. The water pump is the heart of the system, using an internal impeller driven by a serpentine belt or timing belt to push fluid through the engine. Water pumps fail in two distinct ways: mechanically through bearing or seal failure, or hydrodynamically through impeller erosion. The most obvious sign of a mechanical water pump failure is a fluid leak coming directly from the pump sweep hole. A small drain hole designed to vent coolant when the internal shaft seal degrades. You might also hear a high-pitched grinding, whining, or squealing noise from the front of the engine, accompanied by physical wobble in the water pump pulley when you wiggle it with the belt tension released. On the other hand, if the internal plastic or metal impeller blades have eroded away or separated from the drive shaft, the pump pulley will spin quietly, but no coolant will actually move. The classic symptom of an impeller failure is an engine that overheats while idling at a red light, but cools back down as soon as you rev the engine or start driving at higher speeds, because increased engine RPM briefly forces enough liquid movement to dissipate heat. To test for liquid flow, let the engine cool, remove the radiator cap, start the car, and look inside the neck. Once the engine reaches operating temperature, you should see a strong, visible current of coolant rushing across the radiator opening. If the fluid remains completely stagnant despite a hot engine, your water pump impeller is likely compromised. Finally, let's analyze suspect number 3, a clogged or degraded radiator. The radiator relies on dozens of tiny internal aluminum tubes surrounded by delicate cooling fins to transfer heat from the liquid into the outside air. Over time, rust, mineral deposits from tap water, or degraded coolant breakdown product turn into a thick sludge that clogs these narrow passages. Alternatively, road debris, dirt, and bent fins can physically block external airflow through the core. The signature symptom of a clogged radiator is an engine that idles perfectly fine at normal temperature, but begins to overheat specifically when driving at highway speeds, climbing hills, or carrying heavy loads.